NASA's Parker Solar Probe reached the Sun's extended solar atmosphere, known as the corona, and spent 5 hours there. The spacecraft is the first to enter the outer boundaries of our Sun. NASA's Parker Solar Probe has survived a 3-year journey and a roughly 2 million degree Fahrenheit environment to do what was previously thought impossible: enter the Sun's atmosphere. The Parker probe, launched in 2018, has now circled the Sun more than 8 times and has touched the Sun for the first time when it entered the corona, the low-density, high-temperature upper atmosphere of the Sun, in April 2021, according to data published in Physical Review Letters on Tuesday. The probe's mission was to learn more about solar winds, which consist of streams of particles that influence the Earth, as well as magnetic zigzags called switchbacks, and the Sun's surface temperature. The Parker Solar Probe is a NASA space probe launched in 2018 with the mission of making observations of the outer corona of the Sun. It will approach to within 9.86 solar radii from the center of the Sun, and by 2025 will travel at closest approach as fast as 690,000 kilometers per hour, or 0.064% the speed of light. The project was announced in the fiscal year 2009. The cost of the project is $1.5 billion. Johns Hopkins University's Applied Physics Laboratory designed and built the spacecraft, which was launched on 12th of August 2018. It became the first NASA spacecraft named after a living person, honoring nonagenarian physicist Eugene Newman Parker, Professor Emeritus at the University of Chicago. A memory card containing the names of over 1.1 million people was mounted on a plaque and installed below the spacecraft's high-gain antenna on 18th of May 2018. The card also contains photos of Parker and a copy of his 1958 scientific paper predicting important aspects of solar physics. The probe made the first direct observations of what lies within the Sun's atmosphere, measuring phenomena previously only estimated. The Sun's outer edge begins at the Alfvén critical surface, the point below which the Sun and its gravitational and magnetic forces directly control the solar wind. Many scientists think that sudden reverses in the Sun's magnetic field, called switchbacks, emerge from this area. In 2018, NASA launched Parker Solar Probe with the goal of finally reaching the Sun's corona and making humanity's first visit to a star. This past April, the probe spent 5 hours below the Alfvén critical surface in direct contact with the Sun's plasma. Below that surface, the pressure and energy of the Sun's magnetic field was stronger than the pressure and energy of the particles. The spacecraft passed above and below the surface 3 separate times during its encounter. This is the first time a spacecraft has entered the solar corona and touched the atmosphere of the Sun. Surprisingly, the researchers discovered that the Alfvén critical surface is wrinkled. The data suggests that the largest and most distant wrinkle of the surface was produced by a pseudo-streamer, a large magnetic structure more than 40 degrees across, found back on the innermost visible face of the Sun. It's not currently known why a pseudo-streamer would push the Alfvén critical surface away from the Sun. Researchers noticed far fewer switchbacks below the Alfvén critical surface than above it. The finding could mean that switchbacks do not form within the corona. Alternatively, low rates of magnetic reconnection on the Sun's surface could have pumped less mass into the observed wind stream, resulting in fewer switchbacks. The probe also recorded some evidence of a potential power boost just inside the corona. which may point to unknown physics affecting heating and dissipation. The fastest known object built by humans, Parker Solar Probe, has made many new discoveries since its launch, including on explosions that create space weather and the dangers of superspeedy dust. The new findings suggest that direct observations by spacecraft have much to illuminate about the physics of coronal heating and solar wind formation. Having achieved its goal of touching the Sun, Parker Solar Probe will now descend even deeper into the Sun's atmosphere and linger for longer periods of time. We have been observing the Sun and its corona for decades, and we know there's interesting physics going on there to heat and accelerate the solar wind plasma. Still, we cannot tell precisely what that physics is, said Noor E. Rawafi, the Parker Solar Probe project scientist at Johns Hopkins University's Applied Physics Laboratory.